Okay, so we're still looking at geometric sequences and series. Geometric sequences were numbers that go up by the same amount, but they multiply. So if I started with 3, let's say 3, let's do a pen I can see, 3, and I multiply it by 2 every time, so that would be 6, and then 6 times 2 is 12, and then 12 times 2 is 24. This is a geometric sequence. The A value would be 3, because that's what I started with, and the common ratio would be 2, because that's what I'm multiplying by every time. The general term for a geometric sequence then is a special term, Tn, so like the nth term, third term, the 10th term, whatever, is equal to A times the common ratio to the n minus 1. Now this n minus 1 is only with the r. Now we're going to look at geometric series. So we're going to take that sequence that we had and we're going to add it. So a series is just adding a geometric sequence. To calculate the sum for a geometric series, we're going to use this formula, where our sum for n number of terms, so where n could be 10 or 7 or whatever, so the sum of n terms is equal to the first term times the common ratio to the exponent n, the same n is here, minus 1 all over the common ratio minus 1. Remember this one? 2, 4, 8, then we'll go 16, 32, 64. So we're multiplying by 2 every time, so the common ratio is 2, and the initial value is 2 as well. So to write the general term, so Tn then is equal to A, which is 2, r to the n minus 1, so 2 to the n minus 1. So this would be the general term. And the sum, the formula for the sum n is equal to A, again, which is 2 to the n, all minus 1, all over the ratio is 2, so 2 minus 1 on the bottom. So these are the two formulas that we're going to use in order to find T10 and S10. So I'm going to substitute them in. So you can see I've substituted in for the n, I use 10 because that's what I've been asked to do. So the 10th term is equal to 2 times 2 to the 10 minus 1. And the sum of the first 10 terms is equal to 2 times 2 to the 10 minus 1 all over 2 minus 1. Okay, substituting the 10 in and then evaluating, I get the 10th term is 1024, and the sum of all those 10 terms is 2046. For this one, we're going to calculate T6 and S6, and looking at our general term and our sum formulas over here, I can see that I need A, R, and N. Well, we can see the N is 6, and the A is equal to the first term, so 2. The R is equal to what I'm multiplying by every time. So 2 times 5 is 10. 10 times 5 is 50, so R is 5. I will substitute these values into these two formulas in order to figure out T6 and S6. So after substituting the values in and remembering to do the exponent before you do the multiply, so 5 to the 5 is 3,125, and 2 times 3,125 is 6,250. So the sixth term is 6,250. If I take the sum of the first six terms, I'm going to use this formula here, substituting the A for 2, the 5 in for the R, 6 in for the N, and then on the bottom the 5 for the R as well. When I evaluate this, and again keeping in mind that I need to do the exponent and then subtract the 1, and then multiply by 2 and then divide by 4. So my final answer would be 7,812. For these problems, identify A, identify R, and identify the N that you want, and substitute them into this formula up here. A fishy application. At a fish hatchery, fish hatch at different times, even though the eggs are all fertilized at the same time. The number of fish that hatched on each of the first 4 days after fertilization was 4, 12, 36, and 108, respectively. If this pattern continues, calculate the total number of fish hatched during the first 10 days. We can see that this is indeed a geometric sequence because each time we're going up, we're multiplying by 3. So 12 times 3 is 36, 36 times 3 is 108, so it is definitely a geometric series. So let's identify our A, which is 4, and our R is 3. we've been asked to find the total number of fish. So the sum, so total is sum for 10 days. So that means that n equals 10. And now I'm just going to use the formula. I'll substitute A is 4, R is 3, N is 10, and determine the total sum. Okay, so substituting in, I end up with 118,096 fish after the first 10 days. Thank you for listening to our session on geometric series. Good luck with your assignment.